Okay, let's try and cut through some of the noise today. We're diving into drone warfare.
Mm-hmm.
It feels like it's everywhere, but honestly, the language gets confusing fast. You hear drones, counter-drone systems, warheads, blast radius.
It's a lot. And, with conflicts like in Ukraine showing us new things almost daily, plus countries like India really working on using and stopping drones,
Yeah.
well, there's just tons of open source info out there.
Right. So our mission for this deep dive is to take that data, especially from Ukraine and thinking about India's situation too, and figure out what these terms really mean, particularly this idea of radius.
Yeah, radius is the key one, I think. We've got sources looking at counter-UAS systems, that's counter-uncrewed aerial systems, or what they can do, and then other sources detailing the actual impact, the damage zone of drone warheads when they go off.
So the big question for you listening is, what's the real area these things affect? And maybe more importantly, why does it matter so much to know which radius we're even talking about?
Because it might sound simple, right? Radius is radius, but the sources show it's used in, really different ways. Depends entirely if you mean stopping a drone or the damage it does if it isn't stopped.
Okay, let's unpack that. 2 different radii.
At least 2, yeah. When people talk about drone range or effect, radius comes up constantly. But it means fundamentally different things. And mixing them up, that leads to real misunderstanding.
Okay, so one radius is for the systems trying to neutralize a drone before it hits.
Okay, so
And the other radius is about the actual destruction if it does get through and the payload detonates.
Precisely. Let's start with the counter-drone systems, the C-UAS. When we talk about their radius, it's absolutely not about an explosion.
Right, because the sources stress these are mostly non-kinetic. They're not blowing the drone up usually.
That's the key. Their radius is all about detection and mitigation range. Think of it like a bubble. How far out can this system sense a drone coming? And then how far out can it actually do something to stop it?
Like jamming it or...
Jamming its control signals, its GPS maybe,
Mm-hmm.
or blinding its cameras with a laser perhaps, or even physically intercepting it. But the point is, it happens before it reaches the target.
Okay. And the sources give us some numbers here, ranges.
They do. For electronic jamming disrupting signals, you're often looking at, say, 20 to 30 kilometers. Some really advanced stuff, maybe pushing out towards 70 kilometers, potentially using directed energy like microwaves.
Directed energy. That's lasers and microwaves.
Yeah, things like lasers trying to burn sensors or high-power microwaves trying to scramble the electronics inside. Those are more line of sight, generally effective within several kilometers. Still enough to disable it before it gets too close.
And what about actually like shooting them down? Kinetic options. Guns, nets.
Right, the kinetic interceptors. Specialized guns, maybe firing nets, or even another drone designed to catch it. Those engagements, they tend to happen much closer in, usually within 5 kilometers, often less.
So for C-UAS, the radius is that protective zone. It's defensive. How far out can we stop them?
Exactly, it's the engagement envelope, the defensive perimeter.
Okay. Now let's totally switch gears. Drone warhead blast radius. This is about the boom.
This is absolutely about destruction. This radius is the area around the detonation point where things get damaged because of the explosive payload. And it really comes down to 2 main things: how big the warhead is, its weight, and what type it is.
And Ukraine's experience gives us a lot of data on this, right? How it scales.
A huge amount. For the small stuff like those FPV drones you see everywhere, or older kamikaze types using maybe adaptive grenades or small charges, we're talking 1 to 5 kilograms of payload. Sources suggest that translates to maybe a 5 to 15 meter blast radius.
Okay, 5 to 15 meters. What about medium ones?
Moving up, you get things like the Polish Warmate 2, maybe carrying up to 5 kilos.
Yeah.
That could push the radius to, say, 10, maybe 20 meters. Then there are others like the Ukrainian UJ-22 or the Beaver or UJ-25. They can carry different payloads, maybe 3 up to 20 kilos. So their radius could be anywhere from, 10 meters up to maybe 20 or 30, depending on the exact munition.
Even those octocopters dropping grenades.
Yeah, like the Arizvidka R-18. Sources mention it dropping something like a 1.6 kilogram anti-tank grenade. Effective radius maybe 5 to 10 meters against armor. Focus damage.
And then there are the really big ones.
Right. Purpose-built kamikazes. The AQ-400 Scythe, sources say, carries a hefty 32-kilogram warhead. Now you're talking potentially 50 to 100 meters for blast or fragmentation effects.
Wow. And bigger still.
The largest ones mentioned, like the Ukrainian Ludier drone, reports suggest 50 to 75 kilograms of explosives. The estimated destructive radius there could be 100, maybe even 200 meters. That's serious structural damage territory, like a light artillery shell, but potentially delivered from much farther away.
And you mentioned India. Our sources suggest their current FPV focus is on that smaller end.
Seems to be, yeah. That 1 to 5 kilo range, giving that 5 to 15 meter precision effect. Good for tactical targets.
Okay, so just to really nail it down, C-UAS radius is the stopping bubble, potentially tens of kilometers out. Warhead radius is the damage circle, maybe 5 meters to a couple hundred right where it hits.
Exactly. Very different meanings for the same word.
And knowing that difference isn't just, trivia, it actually matters for how these things are used.
Oh, absolutely.
Yep.
It has huge operational implications. The warhead size, and therefore its blast radius, basically dictates what kind of mission that drone is good for.
Makes sense.
Those small FPVs, 1 to 5 kilos, 5-15 meter radius, they're perfect for hitting something specific. A vehicle, maybe a machine gun nest, a weak spot on a building, pinpoint strikes.
Surgical.
Kind of.
Yeah.
Then the medium ones, 10-30 meter radius, better for taking out a whole building, maybe a bunker, ensuring you damage a larger armored vehicle across its whole area.
And the heavy hitters. Ludi, AQ-400.
With those 100-plus meter radii,
Yeah.
they become strategic tools. You can go after big, fixed targets, airfields, fuel dumps, command centers, area damage, like artillery, but flown in, potentially bypassing front lines.
So defending is about the C-UAS bubble size and layers. Attacking is about matching the warhead radius to the target, assuming you can get it there.
Pretty much. Your C-UAS defines your defense in depth.
Yeah.
Your warhead defines your offensive punch if you connect.
But you hinted it's not just about the weight. Other things affect that final damage area.
Right. The sources make that clear. It gets more complicated than just kilograms of explosive.
Okay, this sounds interesting. What else shapes the blast?
Well, the actual design of the warhead itself is critical. How is that explosive energy actually packaged and released?
Okay. Like how?
Think about composition. Is it a fragmentation warhead that's designed to turn its metal casing into lots of high-velocity shrapnel?
So it sprays fragments outwards.
Exactly. It maximizes the lethal area against people or light vehicles, spreading the damage wider, even if the pure blast isn't the main focus.
Gotcha.
Versus something like a thermobaric warhead. Those use a fuel air explosive. They disperse a cloud, then ignite it. Creates a really intense, sustained pressure wave and heat.
Different kind of damage.
Very different. Sources say it's great for structural damage, especially in confined spaces like buildings or bunkers where the pressure builds up. A bigger, longer-lasting destructive effect in that kind of target environment.
So the type of explosion is key. What about the casing?
That matters too. A thicker casing might make fewer but heavier fragments, maybe better for penetrating light armor. A thinner casing might allow more pure blast pressure to escape, better for general structural damage over a wider area, perhaps.
And how it's set off. The fuse.
Hugely important. The fuse decides when and where it detonates. Think about an airburst fuse.
Exploding above the ground.
Right. Sources highlight this for maximizing area effect. Detonating in the air lets the blast wave and fragments spread down and out over a wider footprint. Good against troops in the open or hitting roofs instead of wasting energy digging a crater.
And I guess the target environment matters too. Open field versus city street.
Absolutely. Buildings channel blast waves or block fragments. It all interacts. Which brings us to a really crucial factor the sources dig into. Accuracy?
How close the drone actually hits the aiming point.
Yes. Because there's a difference, the sources say, between the physical blast radius.
Which is fixed by the warhead itself. If it blows up right here, this is the damage circle.
Correct. That's inherent to the munition. But then there's the effective blast zone.
Okay, what's that?
That's the total area where damage could happen, considering how accurate or inaccurate the weapon system is.
So if the drone might miss the target by, say, 10 meters in any direction.
Then the physical blast radius around the actual impact point doesn't change. But the total area at risk, the area where that impact might occur, gets much bigger.
So the effective zone includes the aiming point plus all the possible missed distances around it.
Exactly. Inaccuracy dramatically expands the area you need to worry about, even if the damage from a single hit is confined to its physical radius.
Yeah.
You don't know precisely where within that larger zone the hit will land.
That's a really important distinction. It's like the difference between a sniper rifle and a shotgun pattern at range.
It's a good analogy. Or the sources use mortars. Fire a mortar at long range. Each shell has its own blast radius, maybe 15-20 meters. But due to inaccuracy, the shells might land anywhere in, say, a 100-meter circle. Anyone inside that whole 100-meter circle is effectively at risk, even though one shell won't hit everything. The effective area at risk is way bigger than the physical radius.
And presumably, the more accurate the drone, the closer the effective zone gets to the physical radius.
Precisely. Better guidance shrinks that circle of uncertainty.
So it's not just the bang, it's where the bang happens. And I suppose things like mission profile, autonomy tech, even impact speed can tweak the final result too.
Yeah, they all play a part influencing which warhead you choose, how you deliver it, how the energy transfers on impact.
Okay, that adds layers. Let's talk about distance then. We mentioned those long-range Ukrainian drones. How does distance itself affect things?
It ramps up the challenge significantly.
Yeah.
The sources detail this quite well.
Obvious one is just getting there, right? Range and endurance.
Definitely. You need bigger drones, more fuel or batteries just to cover hundreds of kilometers and maybe loiter. Small FPVs are great nearby, but not for deep strikes.
And controlling them that far out must be tough.
Extremely. Maintaining a solid command link over long distances, especially when the enemy is trying to jam you, is a huge problem. That's why you see more reliance on relay drones, or increasingly, autonomous navigation and target recognition systems. The drone has to know where to go and what to hit on its own.
Which ties right back to accuracy, I imagine.
Absolutely. Hitting a specific point from hundreds of kilometers away is hard. Small navigation errors add up. Weather plays a bigger role. Enemy countermeasures have more time to work.
So that effective radius we talked about, it probably gets worse at longer ranges, even if the physical blast radius is the same.
Generally, yes. The probability of hitting the precise intended target decreases with distance unless you have very sophisticated guidance. Or,
you compensate.
well, maybe you don't need pinpoint accuracy if you use a warhead with a much larger physical blast radius. If you're aiming for a big area target like an airfield parking ramp, getting close enough with a big bang might be sufficient.
So trade precision for bigger area effect to overcome inaccuracy at range?
It's one strategy. And then there's just survivability.
Longer flight, more chances to get shot down.
Exactly. More time exposed to air defenses. Though again, things like better route planning, flying low, electronic countermeasures, they're all trying to mitigate that.
It's fascinating, though, having that long-range capability, even with the challenges. It changes the game.
It really does. It lets you hit strategic targets deep in the enemy's rear command posts, logistics, air bases. That forces them to spread their air defenses much thinner, defending areas far from the front line.
Yeah.
It sort of democratizes long-range strike. You don't necessarily need expensive missiles or bombers anymore.
Okay, that's a lot to take in. Let's try and boil it down. What are the absolute key takeaways from this whole radius discussion?
I think the number one thing is that fundamental difference. Counter-UAS radius is defensive. It's about detection and interception range, maybe out to 70 kilometers or so for some systems.
Like a protective bubble.
Right. And drone warhead radius is offensive. It's the circle of destruction where it hits, ranging from maybe 5 meters for small tactical drones up to potentially 200 meters for the big strategic ones.
Like a damage circle.
Got it. And takeaway 2 is that the size of that damage circle, the warhead radius, scales up significantly with the weight of the explosive payload. We saw that clearly in the Ukraine examples.
And we noted India's current FPV work seems focused on that smaller 5-15-meter precision end, while Ukraine shows the whole spectrum is being used.
Exactly. And the final, maybe more subtle point, is that it's not just weight. Warhead design matters. Detonation conditions matter. And critically, accuracy and target distance matter. They determine the effective area at risk, which, especially due to inaccuracy at range, can be much larger than the physical blast radius itself.
Understanding that difference between physical radius and effective zone seems crucial. It really reframes how you think about these weapons and defending against them.
Definitely moves it beyond just looking at spec sheets. It's about how they actually perform or might perform in the real messy world.
So as we wrap up, here's something maybe for you to think about. Given everything we've discussed about accuracy, distance, and that difference between physical damage and the larger effective zone of risk, how does that inherent uncertainty complicate using these loitering munitions, especially if you're trying very hard to only hit your intended target and nothing else nearby, say in a complex urban area?
Yeah, that uncertainty forces a much harder calculation, doesn't it? It's not just about the target, but everything else within that potential impact footprint.
Definitely a lot to consider there. Well, thank you for joining us on this deep dive into the very different radii of drone warfare.